Okay. Shall I start? Good day. My name is Timur Safin, and I'm the student of, or the student, PhD student of Kazan Federal University. The theme of my report is evidence of coherent magnon state in easy plane antiferromagnet and yttrium iron garnet films. On the same theme was a report of Professor Bunkov on Monday, so I will continue his report. First of all, investigations of magnetics with dynamical frequency shift are of general interest as a relatively single non-linear system of nuclear spins in magnetic materials can be used for nonlinear phenomena simulations, and the possibility of using magnons as information carrier on nanoscale represents a huge importance. Few years ago, by our team or laboratory, the phenomenon of magnon-Bose condensation in solid-state antiferromagnetism manganese fluoride-free and manganese carbonate was discovered and described here. And the main frame of my report is to study this state under different pumping conditions, and try to see correlated phenomena such as Goldstone modes of oscillations and other effects. And some preliminary results on studies of iron, yttrium, garnet will be reported too. So here we can see just as a snapshot of manganese carbonate, of our sample. Near temperature is about 32.5 Kelvin at a volumetry of cell of hexagonal crystal can be watched here. So next, okay. So why these antiferromagnets? These antiferromagnets are like helium-3, where was discovered Bose-Einstein condensation firstly, has a dynamical frequency shift. So, these antiferromagnets have a specific magnetic system where electron spin system is ordered and nuclear spin system is paramagnetic. And a hyperfine field of atoms leads to high polarization of manganese nuclei, and that is why rotation frequency equals to 640 megahertz. And as a result, form coupled nuclear and electron oscillations are formed, and that is why we can see such a non-linearity of our NMR line. So the equation for electron nuclear magnetic resonance line is presented here, and this is external magnetic field. HD, it is a Dzhologinsky field, and this term is a gap in our spectra of FMR. So, and arrow shows the directions of B shows the directions of our sweeping in our sweeping magnetic field in our experiments, and A corresponds to the creation of back. I will talk later about it. So, first of all, we studied our sample by severe magnetic resonance. So here we can see a block scheme. We have a signal generator and transmitting and receiving loop. Here we can see resonator with sample and detection of our signal. The sweep time of magnetic field was about 30 seconds, and field change was about 200 millitesla. And what we have obtained at what we can see here at a lower power of RF pump radio frequency pump, we can see a typical linear NMR signal, and the line width is determined by homogeneous broadening. When we raising our pumping power, we can see that the frequency is captured by the frequency of RF pulse, and it is shifting. And what we are going to do next? So the dot curve is corresponds to a sinus of angle beta. Angle beta, it is the angle of deflection of magnetization. So with this approximation, we can suggest that we have a magnetization on the whole sample. And the next point was to study coherent state. And what we have done, we just stay on this point and make some phase modulation of our RF pump. So, and what can we see here? At frequency shift about 20 megahertz, we can see that at low modulation index, about 0.5 radian, we can see a small additional absorption, and after we rise our modulation, we can see a breakdown. So what we have to do next? We're supposed to change our frequency shift to more just here. We have less coherent state when we speak. And what we can see here, we have seen a linear dependence with the rising of modulation depth. And we can see that the peak of this modulation corresponds to a frequency about 100 kilohertz. And after some and with which frequency corresponds to the frequency of Goldstone modes of oscillations. The now way was the pulse experiments. So here we can see a block scheme. We have a signal generator, pulse generator, switch, which was a multiplier, and on the on exit of a multiplier we have video pulses and the filling frequency, which was determined by pulse generator. The pulse length can be obtained from 0.5 microsecond to 10 seconds, and the rise time of our pulses was about 0.1 microsecond. And what we obtained, as you remember, we have investigated two regimes, a linear and non-linear regime. So firstly, if we stay here in a linear region with a small frequency shift, we suppose our wavelength we might see a typical signal of echo. And what we do, we apply a 2-second pulse, 2-pulse sequence, and receive a signal echo. When we shifted our field to more, when we shifted our field and come closer to the coherent state. And we can see after a long pulse, about 100 milliseconds, we have a long free induction decay signal. So after that, we decided to think what is the nature of this long free induction decay signal. If it is after overheating sample or something like that, or we just after a long pulse we have captured the magnetization of all sample, we might see that when we show change the time between one pulse and two pulses. In a usual case, we might see a signal, a typical signal echo. Never mind what we have here, FID. But we didn't see that. So here we can see the delay between one pulse and two pulses, and here the amplitude of this obtained echo. And we can see that after the delay between only 5 microseconds when coherent state almost breaks, the echo signal starts to form. And another picture, we have also measured T2, and we can see that the time of T2 is much less than the time of our FID signal. And Yuri Mikhailovich have told you about some investigations in iron, yttrium, garnet. So we are trying to study with heat films, and in our experiments we have obtained two cases when we have backward volume magnetic spin waves and forward magnetic static spin waves. And we have made two experiments where we can see pictures which are very similar to which was obtained in helium-free aerogel. And now the aim of our work is to find another correlated phenomena with Bose-Einstein condensation in this sample. Thank you for your attention. Please, questions to Timur?
I don't quite understand. So you have BEC in this approach, or you are going to get it?
No, in our sample, cesium manganese fluoride-free and manganese carbonate, which was I speaking about, we have already get it, BEC. And
so this long coherence signal is associated with BEC, what you just showed?
Yeah.
Okay. Did you try to study it with respect to the power, excitation power? Because BEC of quasi-particles depends on the pumping rate.
Yeah.
And it's quite critical phenomenon. It appears at some critical pumping rate. So
Yes.
it means that if you start to decrease power, you should not see any longer these long decays.
Можно по-русски? Нет, я скажу.
Критичность
Это я понял.
конденсации зависит от мощности. Вы изучали поведение вот этого длинного сигнала от свободной индукции, длинного спада?
Да,
Оно исчезает, если вы убираете, уменьшаете мощность.
Да, еще оно зависит от сдвига частоты. То есть в зависимости от того, насколько мы сдвигаемся от резонансной частоты, поле сдвигаем. То есть в данной работе здесь это не показано, мы это все исследовали, там уже диссертация по этому поводу защищена. Здесь просто и показана картинка, то, что мы можем наблюдать промежуточное состояние, когда у нас вроде как бы уже начинается когерентное состояние наблюдаться, но в то же время есть еще линейность какая-то в системе. И вот, то есть, вот эта картинка я просто хотел показать, то, что мы можем совместить эти два явления. А так это все исследовалось, и действительно там, при уменьшении мощности мы
Спасибо.
видим, что уменьшается.
One more question.
How do you determine that you obtain condensate, Bose-Einstein condensation, rather than just magnon thermalization? And how do you distinguish these states?
So, as I have mentioned before, we have discovered it. No, so the frame of my report wasn't to speak about Bose condensation. I was reporting only related phenomena, and we have made many theoretical. Мы сделали много очень расчетов, то есть все это измерялось, проводилось, и то есть у нас это, ну, мы это доказали. Я вот, часто озвучить, ну, сказать не могу это, но все, все, что есть, это описано в статьях. Почему мы видим BC, а не...
Можно по-русски еще раз это переспрошу, понятно.
Есть два процесса, значит, Боза-Эйнштейн-конденсация и просто термализация магнонов. Это просто вот вы, допустим, возбудили магноны, да?
Да.
И они у вас на нижний уровень, ну, путем там процессов перехода, значит, перешли, то есть термализовались и образовали на нижнем уровне, ну, какое-то состояние. Это не Боза-Эйнштейн-конденсат. Это просто термализованные магноны, ну, как вот электроны, допустим, ну, или Боза-частицы. Просто когда вы накачку убираете, они вот сваливаются на нижний уровень и все. А они, свалившись на нижний уровень, могут там еще образовать вот этот Боза-конденсат, это другое состояние. Вот вы как-то отличаете эти состояния или нет?
Ну, если бы у нас не было здесь Боза-конденсата, то я думаю, что мы не могли бы наблюдать тогда вот голдстоунских моды, которые являются следствием уже этого конденсата.
Какие моды еще?
Ну, голдстоуновские моды.
Спасибо.
Я могу здесь ответить, немножко прокомментировать. Дело в том, что давным-давно наблюдалось, так сказать, и описано конденсация квазичастиц, таких как магноны и ферромагнетика. Это эксперименты Демокритова, и действительно, ведь правильно, не об этом речь. Вот. Но ответ на ваш вопрос заключается в следующем. Они термализуются, но дело в том, что температура настолько высокая, что равновесные их заселенности на основном состоянии, следующем возбужденном, они практически равны. Никакого конденсата нет. А конденсат появляется, когда эта равновесная заселенность нарушается. Вы закачиваете туда магноны, вот, неважно куда, на какие-то уровни, если внутренняя релаксация между уровнями быстро, оказывается, что силы бозоновского характера, они стремятся накапливаться на основном состоянии. В этом заключается явление Боза-конденсации. Проявляется это в длительном сигнале свободной индукции, возникающем из-за основной индукции.
Thank you. Any more questions?